which a number over 1, shrinking comes from
Right. Okay, so stretching and shrinking. I believe with Mrs. Keller, you only did vertical stretching and shrinking, not horizontal. Is that correct?
Yeah.
You guys know? So if you think about stretching, if you like take a rubber band and I stretch it out, what happens to it as I stretch it?
Narrow.
It gets skinnier, and as you shrink it, it gets wider. So in general, we know from yesterday that anything on the outside changes Y, and it does what we say. Anything on the inside changes X, and it does the opposite. So if you multiply a number on the outside, it will be a vertical stretch if C is bigger than 1. It will be a vertical shrink if your C is between 0 and 1. Okay, so multiplying something by 2, it's like saying take all of your Y values times 2. So it's going to double your height, so it's going to get tall and skinny. If I say 1/2, that's taking your height times 1/2, so it's going to get shorter and fatter. Inside changes X, and it does the opposite of what we expect. So it will actually shrink it horizontally if the number is bigger than 1. And it will stretch it horizontally if your number is between 0 and 1. And when we look at examples, I will explain that in a little more detail. The other piece that we are talking about in here is reflecting. What causes a graph to flip? So if there's a negative out in front, out in front changes Y, and it does what it says. So it's like saying I'm going to take your Y value, whatever that is, and make it negative. So if I have a graph like this, if I make all these Y's negative, where does my graph go? Yeah, it's going to come down here. So what axis did I reflect it over? So if you have a negative out in front, we will reflect over the x-axis. And if there is a negative on the inside, so it would be taking my original graph, if I make my x's negative, where does it go? It reflects over the y-axis. All right. Let's start looking at some examples. So we are going to graph each of these. Just like yesterday, I am expecting a parent function and the final graph.
That's what you got on the test.
So if I have 2x cubed, what is my parent function? X cubed, which looks like the chair. Minimum of 3 exact points, but you certainly could have more than that. So 0 cubed is 0, 1 cubed is 1, negative 1 cubed is negative 1. As long as you know it looks like a chair, that's probably enough. But if you didn't, you just plug in some more. Plug in 2 and negative 2, and you'll get your graph. So that's my parent function. All right, stretching and shrinking, sometimes people have a little more trouble with. So what I sometimes recommend, if you have trouble visualizing this, just take a second. These are the 3 ordered pairs we just graphed, right? I've told you that outside changes Y and does what it says. So this says take it times 2. So what I'm going to actually do, it's outside so it's y, so I take all my y's times 2. So 0 times 2 is still 0. So this would be 1 times 2 is 2. Negative 1 times 2 is negative 2. And I'm changing my y values. Does everybody understand how I got those? So if I plot those points, 0, 0, 1, 2, negative 1, negative 2. So then when I graph this, I can see the only thing that changed is what? Yeah, it's going up faster, so it just got skinnier. Okay, I am always going to check for a minimum of 3 exact points, so make sure you have those plotted. You may not have to write out your order pairs. You know, if you can think about it and say, okay, I'm just taking these y's times 2. You don't necessarily have to write the order pairs, but especially when we're first starting, I think that can be helpful to kind of visualize what's happening. Worst case scenario, if you couldn't figure out what this did, how could you get your final graph? Graphing calculator checks it. You need your exact points. Could you plug numbers into 2x cubed? Yeah. We're trying to maybe find a more efficient way, but you can certainly, if you get stuck, go back and make a t-chart. All right, let's take a look at this one. So I have 1/2 x all to the 3rd. So my parent function is still the x cubed. So 0 cubed is 0. 1 cubed is 1. Negative 1 cubed is negative 1. Same points from before. So when we look at this, I'm multiplying my x by 1/2. Inside changes x, but I've told you it does the opposite of what it says. So I'm saying this says multiply x by 1/2, so what would be the opposite of that? Multiply x by 2. All right? So if I take my x's, and I'm going to multiply those by 2. So 0 times 2 is still 0. 1 times 2 is 2. Negative 1 times 2 is negative 2. So those are my new points. 0, 0, 2, 1, negative 2, negative 1. In the previous slide, I told you that if you have, with our x's, if you're multiplying by something between 0 and 1, it's a horizontal stretch. So what I did with this graph is I took it and I stretched it out horizontally, so it got wider. You guys see how I got that one? Why don't you try one on your own? So parent function and the transformation. Alright, so parent function. We know the absolute value is just that v. So that's my dashed one. Make sure you're doing that dashed. If you draw it in solid, then you better be labeling which graph is which. What does this 2 out in front do? It's a vertical stretch. It does what it says. So it is out in front, so it's changing y. So it says times 2, so you take your y's times 2. So we still have 0, 0. Then we're going to get 1, 2, 2, 4. There is a delay in my board today. It's really messing me up. Negative 1, 2. Negative 2, 4. You only had to have 3. I just did a few extras. So 0, 0, 1, 2, 2, 4, negative 1, 2, negative 2, 4. So it's a vertical stretch, so our graph gets skinnier. Okay, so something like that. That's pretty bad, but you know what I mean. If I ask, what's the domain of range? Domain, negative infinity to positive infinity. Range,
0 to infinity.
bracket 0 to infinity. Okay.
Why doesn't Miss Keller just teach it like you teach it? If you're gonna teach it that way.
Yeah.
It's like so much easier. Like it's like not even that much difficult. It's just like
It's just different.
yeah.
It all has to do with like EOCs, I think, have mostly inequalities, so she needs it that way. But ACT has more interval stuff, so we should try switching.
No.
No?
Why can't everybody just follow the same notes?
Why doesn't the EOC just use interval update?
All right, let's try this one.
I don't want to.
Okay, so we have our first function. F of x is the cube root of x.
Oh no.
What does a cube root?
Isn't like this
Yeah.
similar to the, it's like
Similar to the
horizontal.
cube, but like,
Horizontal shape.
You need to scroll down.
so the cube root of 0 is 0, the cube root of 1 is 1. If you did the cube root of 8,
2.
you get out 2.
I'm flying to this homework. Homework. This guy's a goof.
Cube root of negative 1 is negative 1. Cube root of negative 2 is negative 8. Okay, so we've got our parent function. So this one. I'm going to write out my points. You don't have to, but it can be helpful. The first one I'm looking at, the cube root of 3x. Am I going to be changing my x or my y?
Why?
Look at this. My 3 is under, so anything inside is changing x. And x does the opposite of what it says. So it says multiply x by 3, so what will we do?
Divide.
Divide it by 3, or multiply by a third. So 0 divided by 3 is still 0. 1 divided by 3 is 1/3. 8 divided by 3 is 8/3. Negative 1 divided by 3 is negative 1/3. Negative 8 divided by 3 is negative 8/3.
How can you do fraction? The fraction is that.
So let's see, we have 0, 0, 1/3, so a third of the way over. 1. 8/3, that's like 2 and 2/3, or 2.6 repeating. And we'll get out 2. Negative 1/3, negative 1. Negative 6/3, or negative 8/3, negative 2. So that 3 made it a horizontal shrink. It's like we took our graph and we mashed it in from the sides. So the next one, what am I going to be changing? The y. Outside is y, and it does what it says. So it says times 2/3, so we take y times 2/3. So 1 times 2/3 is 2/3. 2 times 2/3 is 4/3. Negative 1 times 2/3 is negative 2/3. Negative 8 times 2/3, or sorry, negative 2 times 2/3 is negative 4/3. So we have 0, 0, over 1 and up 2/3. 8, we're at 4/3, so that's a 1.3. Negative 1, negative 2/3. Negative 8, negative 4/3, or negative 1.3. So this one was a vertical shrink. We took our graph and we made it get shorter. Questions so far? I want you guys to see if you can figure out what this one would be. So our function is negative x squared. So see if you can figure out what that would look like. X squared. X squared is just the parabola. So 0 squared is 0. 1 squared is 1. 2 squared is 4. Negative 1 squared is 1. Negative 2 squared is 4. All right, negative. It's out in front. So what it's doing is in front changes y. So it's essentially going to go through and make all of my y's negative. Okay, or flips it over to the x. So 0, 0 stays. Then we have 1, negative 1. 2, negative 4. Negative 1, negative 1, negative 2, negative 4. So we're just getting this upside down parabola.
Yeah, I think everyone's been on that right now.
Yeah, you're right. We caught it on me.
Look at this one.
I look at orange joking.
What does the square root graph?
It's like the little like.
Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is
she's cheating.
2. I'm cheating. Yes, I am. I didn't erase my grid this time.
Dude, that's unfair.
It is unfair.
Isn't that gonna be imaginary?
Well, you're going to do the opposite of what you plug in.
It's just gonna go down. Or no, it's gonna go opposite direction because you changed the goal. X.
I was just saying,
No, you're not.
you won't put them
We'll
together.
put the same.
If you do the opposite of a negative,
It's positive.
Oh,
it becomes positive.
So
So,
I mean, you know,
Wait, would it just be this one?
what would we say? We can
like
he's
y-axis.
all right, so inside changes x. So if I make my x's negative, we have 0, 0, negative 1, 1, negative 4, 2. If you wanted more, negative 9, 3. You're changing your x's so it flips it over the y-axis. So it looks like that.
Throw me out.
You good, right? We good.
All right,
We good. We good.
let's do,
Nah.
we've learned all the different types So I just want to do some examples that have more than one transformation. So now we know all the possible transformations I could give you.
We might have paper.
Let's do. Let's do this one.
Oh no.
Oh, it's the cube. No, it's not the cube. Sorry, it's the cube.
It's the chair.
Alright. So parent function is going to be a chair. So 0 cubed is 0. 1 cubed is 1. Negative 1 cubed is negative 1. If you wanted more, you could do 2, 8, and negative 2, negative 8. Alright, let's write down what our transformations are. What would this negative out in front do?
Reflect on the x-axis.
Yep, make sure y is negative so it flips over the x. What does the minus 2 on the inside do?
Right, two.
That's from yesterday. And then what does a plus 1 on the end do?
Up one.
Okay. When you are working problems like this, save your up and down movement for last. Most of the time it doesn't matter, but if you have flipping and moving up or down, it does matter which order you do them in. So my general rule, just always do the up and down movement last. So then when I look at this, first point, when I have 0, 0, if I flip that over the x-axis, does it go anywhere?
No.
No. And then we have to move right 2 and up 1. Okay, if I take the point 1, 1, and I flip this over the x-axis, where does it go? Comes down here to 1, negative 1.
Oh.
And then I take my point, right, 2, and up 1. Alright, if I take this point, negative 1, negative 1, if I flip it over the x, where does it go?
Negative 1, 1.
So now we're up here, and then we go right 2 and up 1. Can you tell what your graph looks like now?
No.
Not really.
A little.
Okay, let's do more points.
No.
I
Whoa.
was joking.
I don't.
I think I'm.
Is this supposed to be the same shape?
Yeah.
It's the same thing, just if you flip it over.
Look.
Okay, if I did more points, 2, 8 would have been on my original, right? So if I flip that, it goes to 2, negative 8. Then I take it right 2 and up 1.
Cool.
If I took,
You know what?
We're going off the graph.
if I took negative 2, negative 8,
Oh, no, I got
and
it.
flipped it, it goes to negative 2, positive 8, and we go right 2 and up 1.
Sorry, guys.
So it looks like this.
Yeah, I got it. It was just like the way you said it just made it a little bit more complicated.
He said
Which-
he doesn't like the way you teach.
No.
He just wished we didn't want to sit in a table teacher.
No, I did not.
Let's go back to Stella.
Thanks. I
Wow.
appreciate that.
Sorry.
Way to pick me up for the day, guys. Appreciate that.
But
There you
like-
go, Friday.
During her third hour, Miss
Congratulations.
Breckles
But
was
like
pretty
all
sobbing in here.
I did was move the 0, 0 over and then just went.
And then
Down
you
one
use
to
the
the
pad.
right.
Yeah, that
And
works
then up
too,
one
as
to
long
the
as you know where the other points go. That works as well. All right,
It just confused me.
other questions here?
Nah. So we have our homework today.
Yes.
Let's do one more.
Let's stop here.
Yes!
So, technically, I have taught the whole section, but we still need more practice. There is a Math Excel assignment. You will see when you log into this assignment, it is not due until Monday because it is the homework for both today and tomorrow. So tomorrow, I'm not teaching anything new, but we're going to do more practice with all of this. And then you will have more time to work on the